Okay, today we're talking about rotations. Another way that we can take a polygon and move it around on a coordinate system. So in a rotation, basically you're just rotating the object around a center point. And sometimes you have to define what that center point is. So on our notes, let's write this down. A rotation spins a figure around a fixed point called the center of rotation. For our examples, the center of rotation will be the origin, and will rotate in increments of 90 degrees. This will kind of give you a feel for it and help you get used to it. And additional classes coming down the road, maybe you'll do some rotations around some other point. Okay, figures can be rotated clockwise or counterclockwise. So if you notice the arrows, if you're going clockwise, that means you're rotating like this, the direction this arrow right here shows. If you're going counterclockwise, that means you're rotating in the opposite direction. Consider each quadrant a figure rotates as another 90 degrees of rotation. So we know that a coordinate system is divided into 4 quadrants, each one being a 90-degree quadrant. So if you rotate it all the way around, that would be a 360 degrees. A transformation where the figure turns around a given point is a given distance and direction. Another definition for a rotation. Okay, so let's look at these, and we can kind of look. Remember that the idea that if we have an original figure marked with a letter, then the new figure, after we change it, has a little prime sign on it. So that's kind of how you have to look at this. So if you look at this figure, just imagine like a line going up through here. This is rotating in this direction until you get into this quadrant. And since you're only going one quarter of a turn, then that would be 90 degrees clockwise, because the clockwise is in this direction. This next one, imagine our axis of rotation right here, and it's rotating up this way. So that would be 90 degrees counterclockwise because it's rotating backwards. Well, this next one, almost doesn't matter what way you think about it because it's the same either way. If you rotate it 180 degrees clockwise, you end up right here, or 180 degrees counterclockwise. You still end up on the same line over here. So this could be 180 degrees clockwise or 180 degrees counterclockwise. All right, so we're going to talk about rotating 90 degrees counterclockwise and how it's the same as 270 degrees clockwise. So to do that, I'm going to actually take our little shape and we're going to rotate it starting 90 degrees counterclockwise. So you remember, counterclockwise is rotating it in this direction. So if I rotate it 1/4 of a turn, my new shape is going to look like this. And so if you kind of imagine what are the coordinates of that? Well, A prime would be -4 and 4. So let's write that down. -4 and 4. B prime right here would be -1 and 2. -1 and 2. And C prime right here would be -1 and 4. -1 and 4. All right, so not too bad, right? Now, if you were to rotate this shape back to where it was, and then go clockwise, 90, 180, and 270, you'd notice it'll be right back where it was when we did a 90-degree clockwise rotation. So the numbers would be the same. All right, so how about a 180-degree counterclockwise rotation? So let's get hold of this figure and rotate it 180 degrees counterclockwise. So counterclockwise would be rotating it this way. So that would be 90 degrees counterclockwise, and then one more quarter turn, 180 degrees counterclockwise, which in this case actually turns out to be the same as 180 degrees clockwise. Kind of cool, huh? All right, so if we take a look at that, what are the coordinates of this point? So A prime would be -4, -5, or excuse me, -4, -4, -4, -4. All right, 2, 1 is now -2, -1. So -2, -1. And C prime would be -4, -1, -4, -1. Okay. So basically you're rotating from quadrant 1 all the way into quadrant 3 where both numbers are negative. And the same would apply if you did a 180 degrees clockwise rotation. You'd still be in the same position. Again, how about this one? Let's rotate 270 degrees counterclockwise. So remember, counterclockwise is this way. All right, so let's grab a hold of our image and start rotating. 90 degrees counterclockwise, 180 counterclockwise, and finally, a little too far, 270 counterclockwise. There we go. So let's look at the coordinates of those points. So B prime would be 1, -2, 1, -2. C prime would be 1, -4. All right, so what did we see that was again? 1, -4. And A prime was 4, -4. All right, so what seems to be happening here? Well, it looks like we're switching places between X and Y. So let's see if we can write this rule here. X and Y are transformed by this such that you now have all of the Y values moved to the front. See the 4 and the 1 and the 1. And all of the X values are moved to the back and become their opposites as well. So that's the rule for a 270-degree counterclockwise rotation. So here it is again, kind of summarized. If you rotate 90 degrees counterclockwise, the XY values become -Y, +X. If you rotate 180 degrees clockwise, XY becomes -X and -Y. And if you rotate 270 degrees counterclockwise, that's the same as a 90-degree clockwise. And so these others are also the same as other rotations. You end up with XY is equal to Y, -X. So there you go. Pretty nice, huh? All right, so let's do this. We got a 90 degrees counterclockwise rotation. So to do this, sometimes we have a paper with transparencies on it, and if that's the case, we'll get them out and let you use them. But for my demonstration purposes, I'm going to grab our whole coordinate system, and I am going to rotate it 90 degrees counterclockwise, just like that. And what is the rule? Well, let's go back over here. Remember, our rule is going to look like this. X comma y becomes what? And so hopefully we can do that on both of these while we're at it. X comma y. Okay, now let's go back and rotate that and see what the rule is. Okay, now let's go rotate the entire image and see what happens. So if we rotate the entire image counterclockwise 90 and 180, then what would we notice? Oh, that's too far. We only had to go 90 degrees counterclockwise. So let's go back up to our original image and let's write down the coordinates of one point, all right? So let's say R. The coordinates of R are negative 1 and 2. Negative 1 and 2. So now when we rotate the entire thing 90 degrees counterclockwise, okay, now let's write the new R value, R prime. Let's get a different color. R prime. So to do that, we look at this value right here, and we got negative 2, 1. So negative 2, well, actually negative 2, negative 1. So how can we describe what happened here between this and negative 2 and negative 1? So the original x and y transformed such that the x moved, or the y moved to the front and became its opposite, so we have negative y. And the x value moved to the back and became its opposite. See how that negative 1 moved to the back and stayed the same? So x moves to the back and stays its same. So negative yx is the rule on that transformation. Okay, what about 180 degree? Well, we've discussed this earlier, but if your axis comes down through there like that, and let's pick h for example, negative 2 and 1. So h is negative 2 and 1. Now let's rotate it 180 degrees. And it doesn't matter which direction because it's the same. So 90, 180. Oops, a little too far. All right, so now we notice that instead of up in this quadrant, we're down here in this quadrant. And so what does that look like for that rule? Well, just double check again. Let's go back. Originally we had this, right? And our point was 1, comma 2. This point right here, h is 1, comma 2. We need to do a better job of writing that. So if we look, h is 1, comma 2. Now when we rotate, or that's just regular h, right? So when we rotate it, #90, 180, and we look at h again, our new h value is h prime, which we evaluate to be negative 1, negative 2. So negative 1, negative 2. So looking at the values we have up here and what's going on, our original x and y value changed such that we end up with just a negative x and a negative y value. So negative x, negative y is what happens when you rotate it 180 degrees, either counterclockwise or clockwise. All right, so that's basic rotation. And so you're going to do the basic rotation worksheet. So good luck.